Our eighth topic is the probability of simple events. At the end of this lesson, you are expected to solve problems involving probabilities of simple events. In our previous lessons, we have learned that experimental probability is calculated when the actual situation or problem is performed as an experiment. In this case, you would perform the experiment and use the actual results to determine the probability. And we have two steps in finding the experimental probability of a given event. The first step is to conduct an experiment and record the number of times the event occurs and the number of times the activity is performed. For step 2, divide the two numbers to obtain the experimental probability. For theoretical probability, it is the number of ways the event can occur or the favorable outcomes divided by the number of total outcomes. So for the formula, it is the number of favorable outcomes divided by the number of total outcomes. We also learned that probability is how likely something to be happened or a measure of how likely an event is to occur. You might also hear it called chance. The more likely an event is to occur, the higher its probability. The less likely an event is to occur, the lower its probability. Probability can be expressed as a fraction, decimal, or percentage. And simple event is an event which has a single outcome. The probability of events. The probability of an event or P of event is a number from 0 to 1 which tells how likely the event is to happen. This is the probability line in where if you have 0 probability, then it is impossible to happen or it will never happen. And if your probability is 1, then you have or this event is surely will happen. Between 0 or at the middle of 0 and 1 is 1/2 or your probability is or has a 50% chance. Then that event to happen about is half the time. Between 0 and 1/2 is 1/4 or 25%. So you have a low chance or this given event has a low chance to happen. Between 1/2 and 1 is 3/4 or this given event has a 75% or a high chance to happen. There are rules in probability. The first rule is the probability of any event is a number. It is either a fraction, a decimal, or a percent. So the value is from 0 to 1. For example, the female student population in a certain barangay is 54%. So here, the given probability is in percentage. The probability of female student is equal to 54%. The second rule is if an event will never happen, then its probability is 0. For example, a set of months in a year that starts with the letter K, since the sample space consists of January, February, March, April, May, June, July, August, September, October, November, and December, it is impossible to get K as the starting letter of the month. Hence, the probability of a month in a year that starts with letter K is 0/12 or 0. The third rule is if an event is sure to happen, then the probability is 1. Ayan. For example, when a single die is rolled, what is the probability of getting a number less than 7? Since all the outcomes in rolling a die are 1, 2, 3, 4, 5, 6, and these outcomes are less than 7, then the probability of numbers less than 7 is equal to 6 over 6 or 1. The fourth rule is the sum of the probabilities of all outcomes in the sample space is 1. For example, in rolling a fair die, each outcome in the sample space has a probability of 1/6. For example, the probability of getting a 1 is 1/6. The probability of getting a 2 is also 1/6. The probability of getting a 3 is 1/6. The probability of getting a 4 is 1/6. Same with 5. Same with 6. Now, if we will add these 6 probabilities, then their sum is equal to 6 over 6 or 1. This is the fourth rule. The probability of an event is a ratio that compares the number of favorable outcomes to the number of outcomes. Therefore, the formula is the probability of an event is equal to the number of favorable outcomes over the number of total outcomes. For example, the spinner at the right is spun once. Determine the probability of each event. So these letters in the spinner, ayan, form a word Einstein. So what is the probability of spinning a letter E? This is 2 over 8. So because there are 2 E's in the spinner, and the simplest form for 2 over 8 is 1/4 or 0.25 or 25%. Number 2, what is the probability in spinning a vowel letter? So the vowels here are 2 E's and 2 I's. So we have here 4 vowel letter in this spinner. So the probability is 4 over 8 or 1/2 or 0.5 or 50%. For the third one, what is the probability of spinning a letter T? So since in this spinner, it has one letter T, then the probability is 1 over 8 or 0.13 or 13%. The complementary events. Complementary events are two events in which either one or the other must happen, but they cannot happen at the same time. The sum of the probability of an event and its complement is 1 or 100%. That is our rule number 1, in where the probability of any event is a number from 0 to 1 or 0% to 100%. For example, Miss Joy surveyed her class and discovered that 40% of her students have their assignments. Identify the complement of this event. So the probability of her students with assignment is 40%. And it says here that the sum of the probability of an event and its complement is 1 or 100%. So to make it 100%, the complement is 60%, or the probability of a student without assignment is 60%. So this is the complementary event, or the complement of the probability of her students with assignments. Sometimes, getting an event affects the outcome of another event. Take a look at these examples. For number 1, 2 green and red marbles in the jar. What is the probability that you will get a red marble. So our problem letter A is simple. Our event is 5 and the total marbles in this jar is 7. So the probability of getting a red marble is 5 over 7 or 0.71 or 71%. With the same with the same experiment, what are your chances of getting a red one when you pick again? Ayan, so when you pick again. Ang naging sagot natin sa problem letter A natin is 71%. So this is our first attempt. So for example, ang nabunot mo na ay isang red marble. Red kagad ang iyong nabunot. Now, bubunot ka ulit. Ano na ang iyong magiging probability? 'Di ba? Magiging 4 over 6 na lang. 6 na yung ating denominator or total number of chances. So from this example, naapektuhan yung probability mo sa second experiment. Ayan. So in getting the next marble is affected by the result of the first attempt. Every time you get a piece of marble from a jar. So, halimbawa, nakabunot ka ulit ito, red agad. Hindi ba magbabago ulit yung iyong probability or chances sa iyong pangatlong pagbunot? Yan. So, the chance of getting a red one will change. These are called, itong mga pagbabago na ito, ang tawag dyan ay dependent events. So again, ang tawag dito ay dependent events. My second example is tossing a coin. When you toss a coin, what is the probability of heads landing up? So the probability is equal to 50%. Now, if you toss it again, what is the probability of getting a tail? The probability is equal to 50%. These two events, itong dalawang events na to, si A at si B, do not affect each other. Since the outcome of the first toss is head or tail, this is the same on the second toss, head or tail. So, these events are called independent events. Uulitin ko, kapag sa experiment ay nakakaapekto sa mga susunod pang experiment, ito ay tinatawag na dependent. Pero kung hindi nakakaapekto o walang epekto ang unang experiment sa mga susunod pa nitong experiment, ang tawag dito ay independent events. Nakakaapekto sa susunod, dependent, walang apekto, independent. Let's have some practice. Look carefully at the given set. So this is our set. Numbers from 5 to 16. Determine what is asked. For number 1, what is the probability of having a 12? So ito yung 12 natin. Our event is 1 and the total outcome is 12. So the probability of having a 12 is 1 over 12. Number 2, what is the probability of having a 17? So since the numbers in our set is from 5 to 16, it has no number 17, then the probability is 0. Number 3, what is the probability of having an even numbers? So our even numbers here are 6, 8, 10, 12, 14, and 16. Counting these even numbers or our event is 6 and the total outcome is 12. So the probability of having an even number is 6 over 12 or 1/2. Number 4, what is the probability of having an odd number divisible by 3? These are the odd numbers, 5, 7, 9, 11, 13, and 15. But in these odd numbers, The number that are divisible by 3 are 9 and 15. Therefore, our probability is equal to 2 over 12 or 1 over 6. For number 5, what is the probability of having a numbers 13, 14, and 15? So having a 13 has a probability of 1 over 12. Same with 14 and 15. Adding these probabilities, we have 3 over 12 or 1/4. That's all for your assignment. Determine the probability using the fruit box to solve each problem. So given this fruit box, answer these 5 questions in your notebook. Thank you for listening.